Read your logs down here on the floor. Hello everybody, welcome again to Office Hours. Hopefully you can hear me, hopefully you can see me, hopefully you can do all the requisite things you have on webinars. Thanks very much for joining me. It's once again that time of the month where we get stuck into DBA topics. It's interesting, there's been like, the world has become like sort of like the apps. I got TP on the intro screen. Oh, toilet paper. Sorry, I got what the chat line was. Someone said, you got TP on the intro screen. Toilet paper, I assume. Yes, of course. It's one of those valuable commodities. Yeah, I've got all the most important things to me in the world here. I've got my gin supply, I've got my self-raising flour. The world seems to have been obsessed with baking nowadays, so everyone seems to be baking. So yeah, I've got all the essentials, all the essentials, children's birthday cards, etc. So thank you for noticing. Yes, we try to entertain here on DBA Office Hours. I was going to say, yeah, it's funny how the world has certainly gone virtual nowadays. There are virtual events all over the place, and we'll talk about that in a second. But without further ado, let me share my screen so we can get stuck into it, so we can hopefully finish before the hour is up, because I always run over. Let me share my screen and we'll see how we go. So hopefully you can still see the toilet paper on the slide. So as I always say at the start of Office Hours, in case we have any new people on the call, and anyone that's new on the call, never been to one of my Office Hours, welcome. You're always welcome to attend either in person or in the video that follows afterwards on YouTube. Getting in touch with me is always easy. You can easiest way to reach me is on Twitter. That's at Connor McDonald. But rather than bludgeon you with a million different links, you can just go to linktree/Connor, and there you can get my Instagram, my Facebook, my Twitter, blog, anything, any way you want to get in touch with me, just reach out. I do like talking technology. As I always say at the start of every Office Hours, no need to worry about the slide content being sort of tucked away down at the bottom left. I do that such that when we turn this into a YouTube video, I can plonk myself so I can stare straight down the barrel and virtually see all your faces. So a bit of bits and pieces before we get into the tech content. As you probably know, and this is one of those sad things that's become nowadays, that each time I do an Office Hours, I have to report back on the conferences that are no longer going to be taking place, which is a bit sad. So since we last met, Kscope in June has been cancelled, unfortunately. But as I said, the lack of face-to-face conferences, and don't get me wrong, I'm a huge fan of face-to-face conferences, but the lack of them has opened up the way to virtual. And I'm sort of quietly proud. Office Hours was an initiative of the team I'm in, predominantly by Stephen, my manager, but we all had some input in it. And Office Hours is getting on for past 2 years old now. This is, believe it or not, session 347 of the Office Hours program. So I'd like to think that before virtual became the only way of interacting with our community, I'd like to think that Office Hours is somewhat of a pioneer. I can't think of any other tech events or tech initiatives that have literally gone for almost 350 sessions. All of them free, obviously, and all of them recorded for posterity on YouTube. So I hope you're getting as much value out of them as we enjoy giving them. But as I said, one of the cool things about moving from face-to-face to virtual for the foreseeable future is we have, these amazing opportunities to do inventive things. Office Hours is normally 1 or 2 speakers like myself each month, but we had an initiative the other day where, because of a number of Apex events, the one in Netherlands, the one in Germany, and a couple others had to be delayed or cancelled, we ran this thing called Apex at Home with 24 hours of continuous sessions, and we had 24 speakers. I was lucky enough to be one of them. We even broke Zoom. We started our conference slightly before the hour, and Zoom has a limit, we discovered, of 24 hours for a meeting. And so I was the lucky person on the last session that got booted off in the middle of my talk, but all fun and games. We had nearly 5,000 attendees on that event. That was just insane. So obviously there is a place for virtual content, and as I said, office hours I think has been leading the way of that. A couple of public service announcements. I used to do it's funny how literally only a month ago I put up a slide about the bushfires in Australia in terms of making sure reassuring people that I was okay and that people in Australia were generally okay. It's funny how the world changes. So now this is the slide that I would imagine you've seen many, many times. I'm not going to dwell on the situation around the world and those countries that are obviously most impacted. Australia seems to be coming out of it to some degree, but I just wanted to put that map up to reassure people and to stress to people that office hours is about improving the Oracle community, whether it's be Apex or DBA or SQL or PL/SQL or Spatial or any of the technologies that we have office hours on. It's about increasing the strength of our community, whether it's Oracle people or non-Oracle people, just building a stronger community so we can all prosper. And obviously, critical is if you want to have a community, you need people. And so I can't stress enough, make sure you stay safe, stay healthy, abide by your local restrictions, recommendations by your government, because it would be devastating if we couldn't have everyone that comes to office hours come back the following month. I've had no close friends, thankfully, affected by COVID, but I have had some friends, relatives, who have sadly even passed away. So can't stress enough, stay healthy. We want you to see you, so to speak, on these events from now until the end of time. So if there's anything we can do to help, by the way, in terms of if you want to do a virtual event at your customer site, or you just want to reach out to us and do it one-on-one. I had a good old chat with a friend named Tim, literally for a couple of hours almost this afternoon, because normally we'd catch up at conferences, but I haven't. So please reach out. We want to all help each other here. So this session I put maybe because I always promise a number of content things and then everyone flames me on Twitter for not getting through it. So I've now got the caveat of maybe. This is what we're going to talk about. We're going to talk about cloning databases. We're going to talk about multi-tenant consolidation, SQL Monitor, when does log writer do its writing, and why does the database writer generate redo? They're the topics for this evening, all of which have come from the community in one way or another. So let's get straight into it. Let's talk about cloning databases first. If you have questions, please throw them on the chat line. I'll monitor that probably better than I will the Q&A line. And if I can't answer them in real time, I'll certainly try to take them offline and answer them afterwards. Cloning databases. Here's the question that came in, and do clones count as part of my multi-tenant license limit? And licensing is a valid concern of the community, so I wanted to talk about that in terms of cloning. And the simple answer is yes. Anything which is a PDB, anything that counts as a PDB, if you see it in $PDB, literally if it adds up to that, then it basically becomes part of your multi-tenant license. So let's give a bit of background as to how we got to where we are with multi-tenant and its licensing. And I often start when I'm talking about multi-tenant about this, who remembers multi-tenant? And obviously that's a bit of a play on words because it is the recommended way forward for all Oracle databases, and in 20C it's the only way forward. But I say remember because it's been out now for, since 12C, 12.1 came out, which is, 4 or 5 years. It's been out for a long time, and yet it's perhaps not as widely embraced besides the single pluggable, which a lot of people are using because there's no license fee. And I think that's sad because multi-tenant is just insanely cool. It's so, you think about as a DBA especially, when someone says, can you please copy this database to another database? And it used to be, I got RMAN, I got to look for backups, I got to run a duplicate command, I got to make sure I got my control files and my temp files and all that stuff right. Or I'm running data pump, it's 3 terabytes, I say come back next week and hopefully it'll be loaded, and then the behavior characteristics are different because you've recreated the data from scratch. When you look at something like this in multi-tenant, where literally it's a one-line command, create pluggable copy from another source, you can do it online, you can do it hot, it's just ridiculously cool. It solves so many of those hassles when people come to you saying, I'd like a copy of a database. Or there's the ability to have a read-only copy, which is periodically refreshed from source without having to copy the whole thing again. The ability, it's that common request that come from developers. Here I have a copy, can you please bring it up to date? You can do it with multi-tenant. You can even do it across databases. So with a database link, you can have a pluggable that's refreshed on an intermittent, on a regular cycle. So many goodies once you have a multi-tenant system with more than one pluggable. And of course, not enough people use it because the key sentence there was I said not more than one pluggable, and more than one pluggable means a license. But as I've mentioned in previous office hours, one of the carrots, I don't have a carrot, but I have an orange ball, that'll have to do. One of the carrots we offered out to get people to move to 19C, which is our long-term support release, is if you move to 19C on any edition, standard, enterprise, cloud, on-premise, you name it, you can go up to 3 pluggable databases for absolutely no license fee, no multi-tenant license fee, up to 3 pluggable databases. So those things I just covered, hot cloning, updatable refresh, cross-pluggable cloning, etc., all become available to you, which is really, really cool. Which, that sounds like I'm maybe a broken record there because I've said that before, like how cool the opportunities are now for multi-tenant once you get to 19C. People say to me, I'd like more. I want to have more than 3 pluggables. Or I'm not on 19C. I'm on 12C. I'm on 11. I don't want to upgrade yet, or I can't upgrade yet. Can I have clones, or can I have more than 3 clones? And the answer, believe it or not, is yes as well. And I've put sort of here because we can't do it with multi-tenant technology. But there are other technologies in the Oracle database that exist that might actually suit your needs here. And that facility is known as CloneDB. And CloneDB has been out for a long, long time. It's just one of those hidden, tucked away features that no one has really spoken about that much, which is a pity because I think it's a ridiculously cool piece of technology. It's been there since 11G, so it's robust, it's tried and true, and as long as you're on a supported version of Oracle, which is 11.2 and above, then you'll be able to run CloneDB. To understand what CloneDB is, we have to backtrack a bit and talk about direct NFS. Now, to talk about direct NFS, this is how I came to know about CloneDB, because one of the customers I worked with back in 2015 were using NetApp storage, and NetApp is a NAS-based storage, and so we were running Oracle over NFS. And one of the very cool pieces of technology that came out back then was Oracle's implementation of NFS called direct NFS. And let me explain briefly what that is and how it leads on to CloneDB. If you're just using an NFS on your operating system, like a lot of us do, if we're using shared file systems, etc., or we've got a NAS in the corner, etc., Oracle, like any other program on the OS, would talk to the OS. The operating system would then talk to the NFS layer, which often has some sort of caching facilities, which would then be sent down to the database. All of which is just extra layers that slows things down. Every time you do an I/O, it becomes a bit slower. And the last thing you need on a system which has a database cache, the buffer cache and the SGA, is another cache called the NFS client cache, once again doubling up those writes. It's just a ridiculous use of memory and just more layers that actually slows you down. What happened with direct NFS is Oracle's implementation put the NFS layer into the Oracle kernel, therefore removing the need for those elements. You can still have NFS on the box, but Oracle's not going to use it. It's going to use its own implementation. Now you have Oracle talking directly out to a NetApp or any other kind of NAS filer over NFS. That's super cool because now you don't need fiber channel, you don't need expensive switches, you can literally just plug in Ethernet, which is just getting incredibly cheap and ridiculously fast. You've got 10 gig Ethernet, 40 gig Ethernet via bonding, 100 gig Ethernet's coming, terabits around the corner. It's insane. So having a direct NFS implementation gives you all sorts of benefits, even if we're not talking about cloning of databases. But once the database has full control of writes, it's no longer behooven to the operating system to control the writes. It now has the ability to do things like intercept writes, to reroute where they're going. And that leads us on to CloneDB. So the first thing you need to do if you're going to use any kind of cloning technology, CloneDB, is enable direct NFS. Now, here's the example of what you would do on Windows, and it's very similar on terms of Unix. So on Windows, because I'm going to do a Windows demo in a second, you can see you shut the database down, you copy the current Oracle Disk Management Library, ODM19, to a backup, And then you replace it with the Oracle NFS, Oracle Data Management, Oracle Disk Management libraries. That effectively brings in a set of kernel routines that allows direct NFS. On Unix, it's exactly the same, except it's an Oracle home/lib, and you do it with a symbolic link. But effectively, it's the same thing. I think on Unix, there's even a make command. You can actually make with ins make, and it will actually just do the symbolic link for you. But effectively, you're replacing an existing I/O library with a direct NFS enabled I/O library. So what you need to do then is actually take a full copy of your database first. Now, this takes a little while, so I'm going to actually start something running and then we'll come back to the slides. So all I'm doing, you can see it actually start as we go. I'm simply starting up a fresh copy of a database in no mount mode. So there's no control files, no nothing. It's just the instance. On Windows, it seems to take a long, long time, so I thought I'd start it now. Let's come back to the slides. In order to have a cloning system, what are the kind of attributes we're looking for? We've got a source copy of our database, and we'd like to be able to take clones of that. Now, with a normal pluggable in multi-tenant, we can take full copies, or we can take what we call snapshot copies, which are just very sparsely provisioned copies. If you've got a full multi-tenant license, you can obviously take an unlimited number of them. We'd like to replicate that facility, but using not multi-tenant and not having to pay a full license fee. To do so, the first thing I need is a full copy of the source database. So I take a full copy of the database plus a copy of the control file. That's what I need, a control file and a full backup, and I put as copy. It's not a backup set. We can't use RMAN backup pieces. We need actual image copies of the data files. So I've taken one of them beforehand, and that's what we're going to be using for our cloning. So this is all I've done before this call started. I've simply done allocate a channel on RMAN and backup full as copy database and dumped a copy of the control file to trace. That's really all we have to do. And one would imagine this is probably part of your regular backup cycle anyway. I'll put a link in the description. I've already done a video many, many moons ago on Office Hours talking about the benefit of using image copies as opposed to backup sets for your RMAN backups. So this could be something you could just slot straight into your existing backup regime. We can now build with CloneDB a new database instance, which, believe it or not, is using the backup files as database data files. Now you might be thinking, well, doesn't that break that backup? Because the moment I open the database, it's going to start writing to those data files. This is where direct NFS comes in. We're going to create a new instance based solely on that backup files, and we will never touch them. We're going to read from them. We're never, ever going to write to them. What will happen is when you have direct NFS enabled and you're running in what we call a CloneDB format, you read from that read-only backup. As you try to do writes to the database, direct NFS intercepts them and reroutes them somewhere else into effectively a list of deltas. So what you've got now is the sum total of your database is the read-only backup that you're using, plus all these what we call copy on write, these deltas operations as you make writes to the database. The sum total of that is now a read-write clone of your database, but the only space it's consuming is the deltas because the read-only backup just sits there in place. Only the deltas consume space. Hopefully now my database has started because now we can flick over to the slides and actually look at this in real life action. Let's see how we go. Now, which one was it? Was it this one? Yeah. I wanted to bring up an Explorer window as well. I'll come back to that shortly. Okay. So I've started up a database here. It's just a startup, no mount. So there is no database yet. It is just the instance, the memory, and the processors running. Here's that full here's that full backup. So you can see I've got my 4 data files. This is a non-pluggable instance. I just wanted to keep it small so the demo would run nice and fast. You can see it's a full image copy backup. It's sysorg, system, undo tablespace, and user. It's a very, very small database just to keep it nice and small. But the sum total here is what? If I have a look, it's 1.12. It's about 2.2 gigabytes in size. That's my backup. That's my read-only backup taken from a source database. This is now where things get interesting. I've started up my database instance. The only thing I've changed about it, besides it being a standard database instance, is I've added a parameter which says clone_db equals true. That's the only thing I have to do. I now create a control file. This is a brand new database called, I call it db19c, C for clone. Not C for cloud, C for clone in this case. I'm going to reset logs and it'll be archive log mode. These are brand new ready logs. These don't exist yet. They will be created when I do open the database with reset logs. And you can see I'm pointing to the backup files. So I'm not pointing to new data files, I'm actually pointing to the read-only backup files. And my control file is created. That takes a database from an instance into mounted mode now. So it now has some data files, even though they are just the actual database backups from another database. This is really all I have to do. I have to tell the database how to intercept writes to the read-only files, the read-only backup, and redirect them somewhere else. So you can see for each file I've got, this is the read-only file. When someone tries to make a write to it, write it here instead. When someone tries to make a write to the sysorg table space, write it here instead, and so forth for undo and so forth for the user table space. This is just a simple anonymous block with the dbms_dnfs package, which is a way of mapping writes to the read-only files and rerouting them somewhere else. That's done. Now, just to prove that this is a normal database, that read-only, that backup I took when the database was open. You don't have to shut, it doesn't have to be a clean backup, it can be a fuzzy backup. But what that means is this new database I'm creating obviously needs to be recovered. Those files are actually not in sync with each other. So I have to do a recover database using backup control file. For the purpose of demo, I actually knew what the name of the archive file was, so I directly typed it in, and then I recovered it, and I simply cancelled my media recovery. So I've just done normal database recovery to take advantage of the fact that my full backup was taken in online mode, and my database is now up to date. And I do alter database open reset logs. It's creating some log files. And there we go. This system is actually all done. How cool is that? So there we go. My database is open. This is my clone database. And there we go. It's all running. If I go interrogate this database, it says it's about 2.1 gigabytes in size. At which point you might be thinking, oh, that's a bit worried that, have I cloned the entire copy of the database? If I go look in the actual Oracle NFS system, it also says these so-called deltas, these meant to be small files, are also the full size of the database. It looks like 2 gigs as well. But I've said check the real space, and that's why I brought up an Explorer window beforehand. Let me bring up Explorer and right-click on the NFS folder and choose Properties. So hopefully you can see there, it says, yes, we have 2.1 gigabytes, but the actual size on disk is only 576K. So even though, if I cancel that off, remove that, even though the database says, even on the operating system level, that it's 2 gigabytes, these are actually what we call sparse files. They actually aren't occupying that space. It's only occupying about half a megabyte. And in fact, if I go into this database and just to prove that it is a read-write database, I'll create a copy of a table called T, which is a copy of DBA objects, a copy of a table called T1, also a copy. So I've written some stuff to the database. Let's go back to our Oracle NFS. And we can see it's now gone from 576K on disk to 29.1 megabytes on disk, which is about 2 times DBA objects in terms of size. So while the listing says it's 2 gigabytes, it actually has only consumed 29 megabytes to have a full copy, inverted commas, a full clone of my original database. And so then we do the space check. So that's pretty cool. Let me stop my share. So that's very cool. What we have is this facility where I can take a clone, and you can see I rolled the archives forward, so I can actually roll that database forward a little bit, and it takes up very little space, only the amount of space that'll be used for any subsequent updates. One thing I'm not going to show on the demo, because my PC probably just won't be able to cope with it, is the database never has any exclusive access or exclusive locks on those read-only database backup files. I can create hundreds of clones off that one common set of data files. And what's more, as you saw, because I rolled the clone forward using archive logs, I could have, for example, a backup taken on Sunday. On Monday, I could give someone a clone and roll that backup forward through to Monday's archive logs. I could give someone else a clone and leave it at Sunday. I could give someone else a clone on Wednesday and roll that clone through to all Wednesdays and still leave the other person running a clone at Mondays. There is no limit to the number of clones you can have, besides simply the available space. And the only space that's going to be consumed is deltas. And there's obviously no restrictions on what point in time, as long as it's at the point of time of the full backup or afterwards. That's very, very cool. Let me go back to sharing my screen. So that's CloneDB. You get an unlimited number of copies from the same backup. And obviously, if you had multiple backups from multiple systems, there's no limit. The only thing this is really costing you is a tiny bit of disk space for the deltas. Obviously, the more writes you do, the more deltas space you consume. And the cost of creating an instance. So you lose one of the benefits of multi-tenant in the sense that each one is a brand new instance, which means it needs its own SGA and its own processes. But as long as you've got plenty of memory, and these things are probably not going to be used for industrial strength applications, they're going to be great for building a clone, doing a unit test, throwing it away, doing some integration testing, giving a developer a sandbox, so many useful things when you have a throwaway copy of a mission critical database. That's very, very cool. And as I said, each one can be in different points as time as well. So that's cloning DB with no multi-tenant license restrictions, unlimited number of clones. They can be sparse copies. As you can see, it works on Windows, it works on Unix as well. And all you need to do is activate direct NFS and use the clonedb equals true parameter in init.ora. You've got the control file command, you've got the DBMS DFNS. Oh, let me try that again. You've got the create control file command and the DBMS _ DNFS package, which lets you do the rerouting of data files, and you're good to go. It's very, very cool. You will read in some of the documentation that originally, when this first came out in Oracle 11, the only place you were allowed to store those deltas was actually on an NFS server. It had to be a real NFS server, like something from NetApp or a Filer or a NFS server offered out by Linux, etc. As you saw there, I'm running that entire thing just on my own NT box here with NT local drives. So that restriction has been lifted. That's very, very cool. Okay, I can see some Q&A stuff. What do we got? In 19C, how many distinct pluggable can we run read-write without license? 3. That's it. Okay, only 3. That's it. Literally, as my friend Patrick Wheeler, who used to be I think he might still be the multi-tenant PM, said, you simply do select count star from VDL PDBs, and that's your limit. The easiest way to make sure that you will never hit a license error, and this is the key thing, is in your init.ora on a multi-tenant system, you can set a parameter called max PDBs. If you're going to use PDBs in 19C, which I strongly encourage you to, set max PDBs equals 3, and then you are guaranteed that you will never violate your license because it's set to 3. And the reason that could be useful is some of the cloning technology in multi-tenant, when it comes to application containers, temporarily creates hidden clones to do some work and then releases them. And the max PDBs parameter knows about that. So you might secretly, not even known to yourself, end up with 4 PDBs temporarily while some work is going on. And then by the time you finish, it's back to 3. Max PDBs will help you understand that. Can CloneDB be used with Oracle XE? Certainly, I think with Oracle 18CXE. I haven't tried with 11G, but I'd be surprised if you could not. But yeah, it's definitely with 18CXE because it's a fully fledged version of the database. 929, oh, it's a nightmare. Let's move on. Multi-tenant consolidation, and I'll try to speak faster. I saw a blog post that said multi-tenant means consolidation of things like memory, processes, etc., but also the size of the database. How is that so? You still have the same user data and the same data dictionary. And that's a valid question, because one of the things we talk about when it comes to multi-tenant is if you have 20 databases currently that aren't multi-tenant, you have 20 sets of SGAs, 20 sets of background processes. And in case you haven't looked recently, there's like 60, 70, 80 background processes nowadays in a recent Oracle database. 80 processes on an OS is not a problem. 80 processes times 100 databases is a big drama. But a lot of those background processes don't do a lot. They sit there idle until they're requested to do work. But if you're an operating system and you have to regularly schedule time slice amongst 8,000 processes, even if they're doing nothing, that's an overhead and it costs you. That's one of the beauties of multi-tenant. But obviously, if I have 20 databases worth of data, putting them all into one multi-tenant database is still 20 versions of data. So how does the data get smaller? The key thing is the data dictionary actually gets smaller. And I thought we'd explain how that all works. Let's see if we can get this to see what happens here. So I'm going to run what did I call it? Metadata. I'm currently logged on just as my own user on this database in one of the pluggables. And this is an explanation of how we have kept the data dictionary down to a more manageable size, even if you have lots and lots of pluggable databases. I've picked any one of the dictionary views, DBA source, and the reason I picked that is obviously it's a fairly large table. It's DBA source as a view, but it sits on top of a dictionary table, which is all the PL SQL source for the entire database. It's a large object. If I copied this to every single pluggable I had, especially for all the DBMS packages that come with the database, that would be a big drama. Now, have we done that? Is that what happens? Is that why it takes a while sometimes when you create a pluggable from seed? Let's explore. So DBA source is there in my current pluggable. What if I try get the DDL for that DBA source view in my pluggable? I get an error. And this is the first inclination that maybe something special is going on behind the scenes. It says here that I do not have a view called DBA source in the sys schema in this pluggable database. Now, that's a bit weird, because if I do a query from DBA objects in this same pluggable, it says you've got something owned by sys, it's called DBA source, and it's a view. So it looks like either a bug in DBS metadata or something else going on. We have to dig a little bit further into the dictionary to see how this is hanging together. If I look at the sharing column inside DBA objects, it says, yes, I have a thing called DBA source. Yes, it's a view, but there's this column called sharing. It says it's a metadata link. Now, what does that mean? A metadata link is our way of minimizing the overhead of an individual data dictionary for every single pluggable database. A metadata link says I'm actually a pointer to somewhere else. So let's explore where that pointer might be going. I'll connect now as sysdba as sys, but still inside the pluggable. I'm in pluggable number 1 here inside this database. I try the same thing, go get the definition for the view, and even in sys for this pluggable, I get an error. It's not in there. I need to actually go back all the way to the container root as sysdba. And now I can actually finally get some DDL of some sort. It actually says the view called DBA source is actually just a query from int $DBA source. So it's a view of something else. Now, maybe int DBA source is a table. It's actually a view. We can actually go get the dictionary definition for that as well. If I go look for the view of int $DBA source, it finally looks like the kind of thing you would see in all non-pluggable databases. DBA source in older versions used to look exactly like this. It's a join, we don't have to look at the specifics, but it's a join between sys.source$, where your code is, sys.user$, who owns it. You'll see maybe sys.obj in there, some obj somewhere in there somewhere. It's basically the underlying core dictionary tables. The key thing here is it's only in the container. It's not in any of the pluggables as sys or even as my own user account. So metadata link is our way of saying, as long as you have something in your own pluggable database, which is simply a subset of what's in the container, we can simply point back to the container. All the system PL SQL that comes with the database, DBMS output, DBMS random, DBMS, etc., etc., etc. They are just pointers back to what's in the container. That's the nice way when we plug in. If you create your own PL SQL, that becomes effectively addenda in your own container. But all the stuff that is common between the root and the pluggables literally is only stored in the root, thus shrinking the size of the overall dictionary. You can actually replicate this yourself. Now, please don't do this. This is not actually supported syntax. I just want to show this is how we do it inside the database. You can actually see when it comes to doing, later on when you do application containers, there's this concept of sharing objects between pluggables. We use the same technology from the root down to the pluggables. It's effectively the internal version of application root sharing done as sys. So I can create, I'm logged on as sys, remember, I can create a view called my view. I'm saying it's going to be sharing as metadata, and it's just select username created from DBA users. You'll get an error on that because this is the kind of thing that's not meant to be done unless you're actually doing Oracle dictionary maintenance. So we stop you, and with good reason. The way we avoid it is this is what Oracle maintenance scripts do when you're actually applying patches and the like. We can set a hidden variable. As I stress, whenever you see a parameter with an underscore in it, you don't ever touch these without the guidance of Oracle support. But we're assuming here we're doing some sort of internal dictionary maintenance as advised by Oracle support, and now I can create that view. I then log on to my pluggable, and I can create, I then log on to my pluggable. Let me start that sentence from scratch. I then log on to my pluggable, and you can see that view does not exist in the pluggable. Just because I create it in the root and say it's shared doesn't automatically push it to the pluggables. The pluggable actually has to create it as well. It creates it as its own copy. The syntax is identical. At which point you might be thinking, well, hold on. If I had to create it in the root and I had to create it with the same text in the pluggable, haven't I just got two copies? How do I validate that? Well, if I try get the DDL, if it was its own copy in its own database, its own pluggable, then this would work, and it doesn't. This is effectively a validation that that view does not really exist in this pluggable. And in fact, if I go query DBA objects, you can see it says, I am a shared object. So the mechanism is a bit weird. We create it actually in the root and we create it in the pluggable. But when we create it in the pluggable, we look at the definition. If it's the same as the root, then we can actually have it as shared. You can actually query, it's a real view. I've just queried the first 10 rows. There's no smoke and mirrors. It's a real view. I query the view in the pluggable. It says, the definition is a metadata link. Go back to the definition in the root, get that, use that, and actually run it here in the pluggable. Well, what happens if I manipulate that definition in the pluggable only? I've said, yes, I want it to be shared, but I've given it a different definition. Is that going to corrupt my database? No, it's not. If I do that, the comparison fails. When I go look at my view, it actually is a genuine view now, and it's no longer shared with the root. It's gone. If I recreate it back to exactly matching the root, then it will actually be back to matching the root container, and it becomes a metadata link, etc. So it's all managed for you quite easily. If you divert from the root, it's its own copy. If you don't divert, it's just a pointer back to the root. If I go back to the root now and drop it, what's going to happen? Because does it drop it in all the other pluggables? Because that is the only place where this thing is defined. It doesn't drop it in all the pluggables, but what it does do is break it. So if I now go into my pluggable, it says I can no longer use my view. It says it's invalid or compiled with errors in the root. That's not, I think, a great message because it's not really compiled with errors in the root. It's gone from the root, it's dropped. So I think what they're really saying is it's invalid in the pluggable, or it's valid in the pluggable, but not valid in the root. So poor choice of message, but we are where we are. So I can drop it in the root and drop it in the pluggable, and then it's gone forever. That's how we do it. But as I said, this is just showing you how the mechanism works. Please don't race off setting an Oracle script equals true and manipulating things in that data dictionary, because you're going to end up with a corrupt database for sure. But that's a proof to you. Stop the share. go back to, where are we? That's hopefully a proof to you of how we can keep the data dictionary down to a minimal size. It's only going to be typically one copy of the sys schema with pointers out or metadata links out to all the pluggables. And then your own data dictionary objects will obviously sit in their own pluggable. But one of the good things is you're not going to have a 800 megabyte copy of the sys schema in every single pluggable. And hence we actually do consolidate the space in a multi-tenant database, which is pretty cool. Now we can move on to SQL Monitor. Quick drink. 9:40, okay. SQL Monitor. The SQL Monitor report type for active shows the predicates amongst other things, but you don't get that information from the text version of the report. We don't have internet access from our server, so we cannot use active. How to solve this problem? So we need to talk about a few things here about what the active report is, what the text report is, what do we mean by internet access for the active report, etc. So the concept of active and text comes from the type parameter. And if you're unfamiliar with SQL monitoring reports, this is how you access them. You provide a SQL ID and you simply pass it into DBMS SQL Tune report SQL Monitor, and you type in type of active. And you can choose various kind of report levels. That's beyond the scope of this session. But that's what an active report looks like. And I stress, you really want to use active as much as possible because it's very, very cool. Let me bring up a window. When you run a active, let me go back to that one, wrong one. Let me go back to that one, wrong one again. Let's go back to the slideshow. Whew. When you run this command, it returns you a clob. And so what you do is you spool that clob out to a HTML file, because I've said, yeah, that's what you get by default. Spool it out to a HTML file and then just fire it up in your browser. And that's what gives you something like this. You can see I spooled it out to ctemp SQL Tune active. This can be run while a SQL is actually running. I ran this during the execution of a SQL statement. It can also be run after the fact. And if you run it while it's executing, it will dynamically update each time you run it. You can also access this via Enterprise Manager and also your Service Console Performance Manager in the cloud. So it's available just about everywhere. But it's very, very cool. It looks like a real-time SQL execution plan with all sorts of goodies. It shows you the activity, where the time's being lost, how much, the normal stuff you see in a plan after the fact, but this you can get in real time. It's very, very cool. One of the nice things when you have the active report is you can do things like hover over it. So it shows you how many CPU samples you took, and you can do things like get other information, and in particular, double click on it. And in each line in the row source plan, you can see what predicates were being used. So in this case, it was a join here. If I go down to here, I've got, these are some filter predicates, etc. So lots of goodies that are available to you in the active report. And this is why I say you generally want to use the active as often as you can. Use active when possible. But it needs the internet. And why does it need the internet if it's just something that's being spooled out to a local file and dumped onto your local file system? If you go look at the source code underneath that browser page, the way we are rendering that report is down the bottom here, you can see all this text. It's just basically, I'm pretty sure it's a base 64 encoding of your SQL Monitor report. Might be encrypted as well. And then what we do is we send that up the line to some JavaScript routines that are all sourced from download.oracle.com/here, plus some more links as well. So we're actually going and getting some JavaScript from the web, from Oracle, bring it down, and then processing that information. And that's how we actually render the code. So that's why we need the internet to process an active report. The rendering and the fanciness and the interpretation, some of that is done by using JavaScript, and we get that JavaScript from Oracle. If you do a text report, we don't do any of that stuff. If you do a text report, you get the same information in, no surprises, a text format. However, obviously you can't double click on a text file. There's no drill down facility. And one of the things which I think is perhaps an oversight is in the text file, anything that you would normally drill down to in the active, we don't present. We don't put it further down in the report. You simply don't get access to it. So in this case, that is the exact same report here as you saw from the active one, but obviously there's no predicate information. And predicate and filter information is often critical when it comes to tuning a SQL statement. So it's a bit of a problem. Now you will see some things out on blog posts saying, you know, what you can do is download some of the content that's required for an active report, download it locally and then run it. This was true back in Oracle 10 and 11 when this first came out, but unfortunately is no longer true. It used to be just a few files we download. Now we do a lot of interaction back and forth because the report has become far more sophisticated. So the kind of information you'll see out there in the blogosphere saying you can run it locally is probably out of date and probably won't work. As I said, times changed, you know, that information is out of date. But one of the cool things is the way we implement SQL monitoring is not with JSON, even though JSON's for the cool kids, it's all with XML. If you go look in the DBMS SQL Tune package, it actually says you've got Report SQL Monitor, which is the one we just used, but there's also Report SQL Monitor XML, which gives you the same information back, not as a TLOB, whether it's text or HTML, but just as an XML document. And in fact, if you delve into the internals, which obviously customers are not privy to, you'll see that Report SQL Monitor actually is just calls Report SQL Monitor XML. This is a vast simplification, but almost all the SQL monitoring tools call the XML version to do the actual work. That comes back with an XML, and then we call other DBMS packages in order to format it as HTML or format it as text, etc. So we get a common representation in XML, and then we format it as requested by the user. So if you run it as XML, if we flick to this one, this is what you see. It actually is just the same information. This is the base information that we build all the reports from. And it's just, it starts off as reports, SQL Monitor. You can see start and end time. It's got, you know, who was running it, optimizer parameters, and all the stuff that was actually presented nicely in a report to us is just sitting here in XML, including, if we dig around, things like the predicates. So if it's just XML, well, maybe we can do something with that. Let's get rid of that one. Let's try this one. So because I haven't run an SQL in this office hours session, there's a good chance that this SQL may actually be not in my shared pool anymore. So what I did was I actually ran the XML report and simply stored it in a table called T, so I could reference it for the sake of this office hours session. So normally I would simply say, go get the XML report immediately on the fly. But in this case, we're actually using T as a pre-created table. It's just got the XML report previously stored in it. But because it's XML and an XML type, I can use the normal XML table syntax here. Oh, I might not be connected as the right user here. We'll see how we go. So XML table, drill into the report, drill into the SQL Monitor section, look in the plan, look under the operations, get the name and the ID, and I can actually get the predicates. The predicates might be repeated multiple times, so it's an XML type in itself, and then I can XML table to them. Is this going to work? Yeah. Okay, let's run as the right user and try again. And that's how I've used the XML format to actually dig into the plan, but also pick up those predicates that were missing from the text reports. So if you do want to dig deeper into a SQL monitoring report, whether you're using active or not, maybe there's information in the XML that you'd like to see that the people that wrote the reporting facilities decided you didn't need, you can actually dig into the XML yourself just using your familiar XML table syntax to actually get whatever you want out of the XML format. In this case, you can get the predicates for each of the plan lines. So that's pretty cool. Lots of options there for you. What do we got? 9:50. Can we get another one done? I hope so. Oh, in fact, definitely. This one's going to be fun. When does LogWriter do its work? And this question came in saying, I've read that LogWriter will write out the log buffer to the redo logs when a commit is issued, or when it is 1/3 full. Doesn't this mean we're always just wasting 2/3 of the buffer? Because if the moment my buffer gets 1/3 full and I dump it out to the log writers, well, why did I have the extra 2/3? It seems a nonsense. We're going to have some fun with a demo here. Now, I'm going to turn off my video for a second while I set up. I'll be back in 1 second. Bear with me. Stop the share. Okay. Hopefully you can all see this. Please don't panic. This is not a urine sample. This is just a water jug, and when I put clear water in it, you couldn't see it on the video. So I just added some dye to it to give it some color. So what I've got here is database activity coming in. Redo log buffer down here. Log writer. Redo logs down here on the floor. So we're going to mimic here some database activity. Database activity is continuous. People just continue to always do work. They're always going to be doing work. This is my redo log buffer. So when it gets 1/3 full, log writer has to spring into action. So let me start my transactional activity. There we go. We have workload going on in the database. Now the question was, when it gets to 1/3 full, does everything have to stop? No, it doesn't. So here we have my log writer. Let's add some more transactions. Here we go. Now it's about 1/3 full. So what do? The log writer comes along and dumps it out to disk. Oh, it's 1/3 full. Come along, dump it out to disk. Now, while I'm dumping out to disk, you can see the log buffer is still being filled up. It's still being used by other sessions. So even though I'm dumping it out every 1/3 it gets full, it's not a problem. The reason I need that extra 2/3 is because while I'm busy writing away, transaction activity can continue. That's why we have this thing of, oh, it's 1/3 full, get in there, dump it out to disk. Oh, it's 1/3 full, get in there, dump it out to disk. Maybe it's not 1/3 full, maybe it's only 1/10 full. Oh, someone committed. Yep, grab that, make sure it's on the read your log files. And that's how the log writer works. I better stop this before I blow up my log buffer. Okay, let me pause for a second while I clear my desk. And we're back. And that is how the log writer works. So conceptually, let's have a talk about what's actually going on here. Right? Your session is writing to the log writer, and then it gets dumped out to the reader logs. Now, I want to stress here, the reason I put a few diagrams on here as well is it's not as simple as one water jug, etc. That's conceptually what's going on. And that's fine to think about it that way. But times do change. The way it works in real life nowadays is a little bit more complicated. Obviously, multiple sessions want to write to the log buffer at the same time. And to do that, they have to make sure they don't ask for the same piece of memory. We can have one person writing to here in the log buffer and someone else writing here. As long as they're not obviously overlapping, we're not going to get a corruption. To control that, we have a thing called the redo allocation latch. And there are some other latches underneath it called the redo copy latch. But that's how we get access to different parts of the log buffer. What happens is, in terms of a more modern diagram, is from Oracle 9 onwards, we realized that we could actually have multiple log buffers. So it's not just one log buffer anymore. You'll see this in heaps, your standard documentation. The log buffer is not one thing anymore. It can actually be more than one. And what happens that now gives us the ability to have multiple redo allocation latches. Whenever you have more latches, it means we have more concurrency. More things can go at it at the same time. We don't have hundreds of sessions competing for one latch. We can have multiple redo allocation latches now because we have multiple redo log buffers. So that's the first thing that my little diagram with the water doesn't show, but that's a more modern view of how the redo log writer works. We have more concurrency and scalability now. Now, exploring that a bit further, every time I want to write to the log buffer is when I do a change in redo. That seems sensible.
You might be thinking, well, here's a simple update. I've changed one row. That's one chunk of stuff that needs to go into the redo buffer. But it might not be. It might be, well, to update that one row, I've got to change the table row. But what if there's an index on the employee name? Well, I need to delete the index entry for Michael and replace it with Mike, if that's what the update is. What if there's an index on department number because it's a foreign key? I need to, if it's going from 30 to 20, I need to delete the index entry for 30 and replace it with an index entry for 10. Oops, that should be for 20, shouldn't it? If I'm setting it to 20, database corruption. You get the idea. So a single update of a single row has 5 changes going on. What does that mean? 5 chunks of little bits of things going to redo, 5 chunks of getting the allocation latch. That's obviously perhaps a concurrency limiter because every time I go for a latch, I might be blocking someone else. Plus, there's all the undo. For all those 5 changes, there's the undo information to roll it back. So we've got 10 small little chunks of changes here that actually comprise just one update. And all those 10 might be actually asking for the redo allocation latch. Can we do better? Here's our second modernization of my diagram and demo. We have multiple log buffers. We also have these things called private redo buffers nowadays. And unlike the log buffer, which is shared by all sessions, the private redo is given to a particular session. So a session no longer has to write directly to the log buffer and compete for the allocation latch. It can write to the private redo area. So now when you do that one row update, which results in lots and lots of little tiny changes, they can all be sent to this private redo area. I no longer had to compete for that redo allocation latch. When the entire chunk of work is done, when I want to commit that transaction, now I can copy it in one hit to the redo log buffer. And I have to get the redo allocation latch for that, but I got it once as opposed to 5 or 10 times. That improves concurrency as well. And we have multiple private redo buffers. You'll see that you hear them referred to as strands, and a session gets allocated to one of them. And that's how the more modern version of this diagram. Now, there's a lot not covered here, but I stress there's a lot that we don't need to cover here. I put this here just to make sure that people don't accuse me of lying with my diagram with the water, with my demo with the water. And that hopefully brings your knowledge a little bit more up to date with how we've improved redo over the years, over and above the old style of single log buffer, single latch, etc. But that's about as much detail as you need. You don't need to understand the incredible intricacies here. Just know that now that redo has greater concurrency and greater availability. Now, I think I've got one more to go. It's 9:59. I think this one doesn't take long. We're gonna charge on. We're gonna charge on and finish off. So please bear with me. Okay, redo generation. Of course, my connected application sessions will generate redo. They're going to do updates and deletes and inserts, etc. But I see redo generation coming out of the DB writer process. Why would DB writer generate redo? Now, because this will be a video in its own right, I want to stress that we need to understand some preliminaries here for those who haven't been on the call the whole time. So if this is the first you've seen of this diagram, I'll put a video link in the description when we get to YouTube showing you how we came across the concept of private redo. But we need to know that we have private versus public redo in modern versions of Oracle, like we've just covered 2 minutes ago. What happens is sessions write to private redo, and then the private redo will be flushed to the log buffer, the public log buffer, and then the log writer would take care of flushing that down to the database. Now, in the good old days, when we didn't have private redo, all the sessions would write to the log buffer, and then occasionally the database writer needs to do things like a checkpoint, and it needs to make sure that all those log information is flushed out. So it literally says, hey, log writer, please flush out the redo. I need to do a checkpoint. That's an easy request for the DB writer to do because it simply posts the log writer, literally sends it a message saying, hey, do your job. I need to do a checkpoint. Let me know when you're done. That works because the only place redo information is in the log buffer. In modern versions of Oracle, well, we have stuff in the log buffer, but we also have sessions with their own private redo inside their own private redo log buffers. Now when DB Writer says, look, I need to actually do a checkpoint. I need to make sure the redo log is flushed. It now has the job of going and getting all that private redo information from each of the sessions that are using it, making sure it's dragged down into the log buffer, and then tells log buffer, hey, flush that stuff out. Now, you get an interesting statistical anomaly here. The act of DB Writer getting information out of those private redo buffers and dragging them into the public log buffer, so log writer can dump them out to disk, that is actually called redo for DB Writer. It actually contributes to the redo size statistic for DB Writer. And in fact, if I log onto my database and I ran this query before office hours started, you can see that for the program called DBW anything, for redo size, this database has done, what do we got? 15 megabytes of redo. So DB Writer hasn't actually written out to the redo logs. What it's done is 15 megabytes over the life of the instance of having to go drag information out of private redo buffers, put it into the public log buffer such that log writer can do its job so DB Writer can continue on and do what it needs, for example, a checkpoint, etc. And we're done. Only a little bit late, 3 minutes late, but hopefully that's been an entertaining session for you. Let me stop my share. Hopefully we had some fun with the water. Thankfully, nothing doesn't look like my PC has got any water damage. Thank you once again for attending. It's always a pleasure to have you on the call, and we'll be back again in a month. As always, feel free to reach out to me over Twitter or any other social media. And if you ever just want to have a Zoom call with your customer or to have a chit chat about tech, yeah, always happy to have a chat. Thanks everyone. Thanks for coming along, and we'll see you in a month's time or somewhere else in the virtual world. Bye for now, everybody.